Okay, so in this example, we're given an equation that relates the final velocity to some other variables, and we're asked for the dimensions of VF. So in order to find that, we just need to remember that any equation needs to be dimensionally consistent, meaning the dimensions on the left-hand side have to be the same as the dimensions on the right-hand side. So in order to answer this question, we have to basically know the dimensions of the entire right-hand side of this equation. So I'm going to put brackets around each of the individual variables to indicate that I'm examining their dimensionality. So the dimensions of initial velocity are just going to be a length divided by a time. And then when it comes to a combination of variables, you could just treat the dimensions algebraically, right? So for example, acceleration is a length divided by a time squared, multiplied by a time. So we're seeing another thing that is required for things to be quote unquote dimensionally consistent. Namely, you can only add two or more things that have the same dimension, right? So I could add a length per time with another length per time. And ultimately, this tells me something that's not very surprising, which is that the final velocity should also have dimensions of a length divided by a time.